Well, it's certainly a great honor for me, too, to be here. I'm greatly honored to present Pete Vail, one of my best friends, as one of our geolegends for 2006. What makes Pete a legend? Well, that's pretty easy, you know, because after 50 years, he's become one of the best-known geologists in the world. His articles have been translated into all major languages, including Russian, Chinese, and probably some others I can't pronounce. He leaves a trail of influence through both industry for many years, as well as academia, as he was a professor at Rice. Pete is special. He really is special because he combines two great gifts. Not everybody has two gifts. He has the gift of creativity, but he also had the ability to organize and develop this creativity into workable concepts and systems which have been applied worldwide in both industry and in academia. Most of our modern stratigraphic thought is organized around his concepts, and he's changed how people think and work on a daily basis in the broad field of stratigraphy. Pete's concepts are based on the general idea that sea level has been cyclically rising and falling throughout geologic history, and that these cycles have produced synchronous bundles of strata, globally synchronous, that he calls sequences, recognizable in seismic reflections, in well logs, and in outcrops. All the applications of sequence stratigraphy have come from this basic idea. Pete's career has been divided between 30 years at the old Exxon Production Research Company, now ExxonMobil Upstream Research, and then 15 years as a professor at Rice. He became an emeritus there in 2001, but he still actively consults in Houston. And he started a third career, which he'll probably tell you about. He received so many awards that I'd use all my time if I tried to recite all his awards. It's really very satisfying that the concept of sequence stratigraphy has not stopped with Pete, but now has a life of its own with contributions from second and third generation stratigraphers, many of whom are in this room. This continuing growth has guaranteed Pete Vail the status of a legend. And so it's on this note that I give you Peter R. Vail as one of the HGS geolegends that we are honoring tonight. Peter?
Thank you, Bob, for that nice introduction. And good evening to all of you. It's a real pleasure to see. It's a real pleasure to see so many people turn out for this event, and I'm real happy to be here. I've been fortunate in my career to have worked in three areas of the profession. Bob went over those. I worked for a major oil company, Exxon Research, for 30 years, and then 15 years at Rice University. And now, 5 years in counting, I have my own oil and gas company. My career starts back at high school in Ridgewood, New Jersey. I was a junior and not doing well academically. So my father, who was a very strong-willed person, sent me off to a boarding school called Deerfield Academy in Massachusetts. The headmaster, Mr. Boyden, had a reputation for turning around kids like me. And it really helped. I ended up winning the class science award at graduation. At Deerfield, I took all the science courses, including biology and geology. My grades at Deerfield enabled me to be accepted at Dartmouth College, where I wanted to major in biology. Geology at Dartmouth was oriented towards pre-med, and I didn't want to be a doctor, so I decided on geology. When I decided on geology, I told my mother, I told her, well, I'm going to major in geology. And she said, what denomination? She never heard of geology and thought I had said, of course, theology. At Dartmouth, all geologic field trips from campus dealt with igneous and metamorphic rock, which has not really turned me on. Fortunately, we had an extended field trip to New York State, where we studied some of the classic sedimentary rock formations. After the trip, one of the professors, Carl Moritz, observed my enthusiasm for sedimentary rocks, and he told me I should go to graduate school at Northwestern University and study under Larry Sloss. He worked with Sloss in Montana. So Professor Moritz helped me get accepted with a teaching assistantship at Northwestern. It turned out Sloss had all the graduate students he could handle, so I was officially a Dapples student. Dapples was a sedimentologist, and I learned a lot from him, as well as Crumbine and Sloss. My office mate was Bob Mitchell. John Sangre and John Hefner were also there at Northwestern with me. After my first year, I was awarded the Shell Fellowship, which paid all my expenses. I really appreciated the fellowship and thought I would end up by going to work for Shell. But when it came time to apply for jobs, Shell offered me, in the short term, a one-year training program. Exxon offered me a Pacific Research Project. I had been in college now for 8 years, and so I was anxious to get started working on my own project. So I went with Exxon's Carter Research Lab in Tulsa. My project was to evaluate Crumbine's mapping techniques. At Carter, my office mate turned out to be Bob Mitchum again. But Bob was doing a stratigraphic study of the Paradox Basin, so I used his data to construct all the Crumbine type maps I knew about. Then during the summer, Carter hired Crumbine to visit the Carter and Humboldt field offices. I went along with him and would show my maps, which Crumbine would discuss. After I showed my maps to the operating geologists and geophysicists, they would discuss their stratigraphic projects with Crumbine. Crumbine would advise them on mapping techniques. I did this for 2 summers and got a good feeling for how Humboldt and Exxon explored for oil and gas. The major thing I learned was that the mapping technique was not the major problem. The major problem was the time stratigraphic correlations of the mapping units. So I ended my mapping techniques project and then worked with John Sanger, who joined Carter Research, and Chuck Campbell on correlation techniques. We concentrated on detailed marker bed correlations in shale sections and wrote a paper on the patterns we recognized. We called this paper Pattern Correlation. After the pattern correlation report came out, the company, a seismic interpreter named Paul Tucker, came to my office and told me you could see all these patterns on seismic data. I said, really? And he took me to his office and showed me on lap, off lap, and down lap, and it was so. I was so impressed I decided I didn't need to learn more geophysics. So I requested a transfer to the geophysics research section. What I didn't know, I was joining a group of theoretical mathematicians and theoretical geophysicists. After a month or so, my group leader called me into his office and told me I had no future with Exxon. Because I just didn't understand enough mathematics. My rating on the seriatim was dropping, so I decided I'd better find a good project and find it fast. What I found was a problem in Portuguese Guinea, Africa. Exxon had drilled a discovery well in an on-lapping Cretaceous sand reservoir. The seismic interpreters on the project had traced the reflection from the top of the sand out into the basin, where it crossed a structure with closure on the reflection. Exxon drilled a well on this structure and only found silt and shale at the predicted reservoir horizon. What went wrong? I decided this was a good project for me. The first thing I did was to get a biostratigrapher to age date the reservoir interval on each well. The ages were the same. But what happened to the reservoir sand? It had obviously phase changed to silt and shale. Why Why was there a continuous reflection when the sand formation was going? The reflections correlated with the geologic time, but not with the top of the reservoir rock formation. CVL logs were available, so I made a impedance cross-section between the two wells following the marker bed correlations. A geophysicist friend named Frank Remisa modeled the section for me on an analog equalizer machine. The synthetic seismic section he produced showed that the high amplitude reflection stepped up on stratigraphically as the reservoir time transgressed the basin margin. The continuous reflection out of the basin was caused by constructive interference of low impedance reflection pulses that followed the physical stratal surfaces. And so I concluded the reflections follow the physical stratal surface that approximate geologic timelines, and that they do not follow tops of the time transgressive rock formations. The high amplitude events at the top of the rock formation stepped up as the reservoir formation onlapped the basin margin. This was a fairly simple explanation, but it met with a great deal of disbelief in the company and in my talks at the geological conventions. With this concept in mind, I began interpreting seismic sections in terms of geologic time. I found the best way to subdivide the stratigraphy on the sections was to correlate onlap surfaces. The onlap surfaces were unconformities and the relative conformities. The interval, these surfaces brought me back to my work with Schloss at Northwestern, where Schloss had worked with the intercratonic sequences. My intervals were much shorter in duration, but they had the same physical characteristics. So I called these unit sequences. After interpreting sequence like this in many basins around the world, I found I could recognize the age of the sequences in the Oligocene from the onlap pattern. I called this the Oligocene seismic signature, the Oligomycene seismic signature. I organized a seminar class when I was at Wright to prepare a paper on this subject, which we did. Andrew Draxler, my colleague, professor at Rice, and his students, and did several studies which also documented this Oligomycene pattern. I also observed an onlap pattern at the basement edge of the sequence. Some sequences tended to be widespread, others restricted to the basin. So I made an onlap chart of this pattern and age-dated the sequence boundaries at the conformable surfaces with biostratigraphy. I got Exxon's biostratigraphy department to make me a time scale for the tertiary, so I could put my onlap chart against the time scale. With further testing, the chart seemed to be holding up, so we extended the chart down to the base of the Triassic. While I was at Rice, I attended a geological meeting and sat with a friend named Walter Warnock. He told me he could identify the maximum flooding surfaces of our sequences based on the abundance of fossils. I was interested, so we met afterwards and developed a sequence and systems track interpretation procedure for well logs. We then taught this at Rice and then gave a number of two-day seminars around the country. At Rice, I took a sabbatical in Europe. My objective was to document the sequences on our on-lap chart with the classical stratigraphic outcrops sections of Europe. I did this work in collaboration with Jan Hardenball of Exxon and two French stratigraphers. We were able to document the sequences on the chart, plus a few corrected ones we later found to be also local. This work and chart resulted in SEPM Memoir 60. During my sabbatical, I ended up giving myself a cerebral hematoma, and that paralyzed my left side. When I came back to Rice, I taught for a while, but didn't feel I was doing well enough, so I decided to retire. When I retired, I realized I didn't have enough to keep me busy. So I figured if I wanted to live as long as my IRA actuary table said I would, I should get busy. So one of my long-term goals was to actually find oil and gas for my own account. So I set up my company, PR Vail Oil and Gas Company. I wanted to consult and earn interest in drilling wells. I found this was very difficult to do. The companies I worked with were more interested in me investing money in these wells. So I talked to a friend who was an investor, and he told me, make sure you never invest more money than you have to live on. So after retiring from Rice, I realized I had two IRAs. So I decided I would invest the Rice IRA and live on the Exxon IRA. I've done this, but I find I'm nibbling away now at the Exxon IRA. I invested mainly in what they call PUDs, proven undeveloped reserves. My investments were initially sold. As a result, my success rate is over 90%, but I don't make a lot of money. The checks are sold, but they add up slowly. Recently, I have upped my investment amounts, and things seem to be going better. Just last month, a well I invested in near Benham, Texas, in Washington County, came in with 27,800,000 cubic feet of gas per day. I had a fourth unit in that well, which is a 0.5%. That doesn't seem like very much, but with today's prices and that tremendous volume, they're going to produce it between somewhere between 8 and 12 million, and it still adds up to a good monthly gas. So I'm very pleased with that. And it looks like I might get 2 or 3 of those. Of different wells. As for the future of the oil and gas exploration, I find there are still a lot of good oil and gas prospects for drilling. At the present cost, the price of oil and gas stays high, exploration should continue for quite a while. As to deciding on a geologic career or not, I believe the thing to do is to find out all you can about what you are interested in, and then and you will know what to do, and then do it and stick with it. Well, thank you very much.
Thank you very much, Dr. Vail.